In this presentation, we are going to see about data link layer and noise classification. Before that, let me introduce myself. I am B. Aishwarya from 3rd year ECE. Now let's dive into the presentation. So, first let us discuss what is data link layer in IEEE 802 project. The data link layer defined in IEEE 802 project is the second layer in OSI model of networking when considered from the bottom. Its primary function is to facilitate reliable data communication between devices in the same local area, that is LAN. It performs other specific functions which include data framing, addressing, error detection, and control of access to the communication medium, making it an essential component for data transmission in LAN environment. It is also used for node-to-node data communication in communication systems. Now let's see classification of data link layer. The data link layer in networking is typically divided into two sublayers. First one, the logical link layer called the LLC. Second one, the media access control layer called MAC. Each sublayer has its specific functions. Let's discuss. First, logical link layer LLC. It performs the following functions which include flow control, error detection, logical link management, frame delimiting. First, flow control. This layer manages the flow of data between devices to ensure that data is sent at a rate the receiving device can handle. It helps prevent data overflow and congestion. It handles error detection in ensuring integrity during transmission. It is responsible for establishing, maintaining, and terminating logical links. It coordinates data exchange. Frame delimiting. LLC frames are used to delimit data to be sent, ensuring that the receiver can correctly identify the boundaries of the data. Now let's see media access control. Addressing. MAC assigns unique media access control addresses to each device on the network. They are used for source and destination identifications, frame creation and encapsulation. The transmitting data from the LLC is sent unsegmented to the MAC, where it is segmented into smaller pieces called frames. These frames are encapsulated into a larger frame which is encoded with source and destination addresses to make sure that where it is sent from and where it has to be reached. Then frame synchronization. It ensures that the frames are synchronized correctly so that the receiver can interpret correctly. Error detection. MAC performs error detection such as checking for frame integrity using CRC. CRC means cyclic redundancy check, or it is also called check bits. Frame addressing. It uses destination MAC address to determine whether a frame should be accepted by a device. Frames with matching destination addresses are processed while others are ignored. Now let's see the noise classification. Noise classification basically depends on whether the transmitting channel has noise on it. So, in information theory and communication systems, the two different types of communication environment are one, noiseless channel, and second, noisy channel. If the transmitting channel has noise on it, it is called noisy channel, and if it is not, it is called noiseless channel. Practically, noiseless channel is impossible to create. Let's discuss further. Noiseless channel. This is an idealized communication channel where information can be transmitted without any errors. In a noiseless channel, the transmitted signal arrives at the receiver exactly as it was sent without any corruption or interference. Noiseless channels are mainly used for theoretical analysis and are not encountered in real world scenarios. Noisy channel. Noisy channel is a communication channel where random interference or noise can corrupt the transmitting signal. If we can say that the received signal is equal to transmitted signal plus unwanted disturbance or noise. While in noiseless channel, it is the received signal is equal to the transmitted signal without any noise. This in noisy channel, this noise can introduce errors or distortions, making it challenging to accurately receive the information at other end. In practice, most real world communication channels such as wireless networks, telephone lines, or radio waves are noisy to some degree. Even if we use some filters or modulation techniques, it cannot eliminate the error completely but can reduce the error to a certain extent. Conclusion. To mitigate the effects of noise in noisy channel, error correcting codes and various modulation techniques are employed. These methods add redundancy to the transmitted data, allowing the receiver to detect and correct errors caused by noise, thereby improving the reliability and integrity of the communication.